Hi, welcome to AB Video 2.2e Part 1, more on vertical motion. So, this is number 98 on page 117. Remember we were talking about the position function. S is the height of the object from the ground at time t. So all these t's represent the time since the ball has left the hand of the person who's tossing it or dropping it. V0 is the initial velocity of this object. This in case is a ball. And S0 is the initial height. So a ball is thrown down. It's not dropped and it's not thrown upwards. It's thrown down from the top of a 220-foot building. So that's our initial height, with an initial velocity of negative 22 feet per second. Now the reason that initial velocity is negative is because the object is being thrown downwards. So there's our equation. S of t equals negative 16t squared minus 22t plus 220. Find the velocity after 3 seconds. Well, the velocity is the derivative of the position function. So find v of 3. You start by finding v of t, which is the derivative, which is s prime of t, or ds dt. The derivative of this is negative 32t minus 22, and therefore the derivative at 3 is negative 32 times 3 minus 22, which turns out to be negative 118 feet per second. Now, the second part of the problem, you have to be careful. Find the velocity after the object has fallen 108 feet. So it starts up here at 220 feet, it falls 108 feet. At that point, it is 112 feet from the ground. So you never plug in 108, you actually are going to use 112 as the height at that moment. So what is the velocity after the ball falls 108 feet? So the height from the ground is 112 feet. We're going to have to start with the position function in order to find out at what time, how many seconds it takes for it to get to this height of 112 feet from the ground. Because remember, in order to find velocity, our velocity function is in terms of time. So we have to find the time at which that happens. So we take the position function, we set the position to 112 feet above the ground, and we now know that our initial velocity, we know from the words of the problem, the initial velocity is negative 2 and the initial height is 220. So you're going to solve that equation. You get two answers. Negative time doesn't make any sense. So it happens after 2 seconds, and therefore the velocity at 2 seconds is negative 32 times 2 minus 2, which is negative 86 feet per second. Now it's very important that you understand that you have to give the correct units of measure. A velocity, as we said, a velocity is the derivative of height with respect to time, or distance with respect to time. The height in this case was measured in feet, the time was measured in seconds, and that negative is crucial because that object is on its way down and therefore has a negative velocity at that time. This is like number 11, number 100, not quite number 100. A stone is dropped, that's a key word right there, from the top of a building into a pond which is at ground level. How high is the building if the splash is seen 6.8 seconds after the stone is dropped? Okay, so first of all, this is number 100, and they're giving you the position function. Everything's being measured in meters, not that you would know that from the words of the problem, but they are telling you that that's what's happening. So here's our position function, and it's in meters. So what happens is, how high is the building? Well, how high is the building means we're looking for S0, the initial height of the building, because the stone is dropped from the top of the building, and we're looking for the height of the building. So we're looking for S0. Considering it was dropped, the initial velocity is 0. So what we have is negative 4.9t squared. The initial velocity was 0, so that's plus 0t plus S0, which is what we're looking for. What we know is that 6.8 seconds after the stone is dropped, you see a splash, which means it takes there's our paraplegic, and he's throwing stones now. 6.8 seconds later, it's on the ground. So when it hits the ground, what we know about it hits the ground, and this is very important, is that the height is 0. The velocity is not 0. I know you know this thing from physics called terminal velocity, but we're talking a microsecond before it hits. It's not traveling slow, believe me, this rock. If you were standing there in that pond, that rock would hurt your head because it's traveling quite quickly. So what we have is we know that the height is 0 when it hits the ground, so we purposely set the height equal to 0 in the height equation, and I'm just going to call that S0h because it's the height of the building. The distance from the ground is the same thing as the height of the initial height. And then I set that height equal to 0. I solve for the height of the building. I know it happens 6.8 seconds. That's my time, and you'll find out that the height of the building is 226.6. I think my thing is running out of battery. Note the velocity when it hits the ground, if they asked you that question. Hang on a second. Alright, sorry about that. My wireless headset battery was running out, so I'm wired in now. Okay, if they asked you what's the velocity when it hits the ground, we know it hits the ground at 6.8 seconds. The velocity, of course, is the derivative of this position function. So the derivative of our position function is negative 9.8t plus 0, because the initial height is just a constant. So negative 9.8 times the 6.8 seconds would give me that its hits, when it's just before it hits, it's traveling at negative 66.64 meters per second. In other words, if you were standing in the way. And that's the end of video 2.2e, part 1.